Welcome to my channel, Amateur Radio Universe. Today in this video, I am going to talk about a different type of LC oscillator, which is the direct coupled transistor Colpitts oscillator. We have already gone through the basic theory and construction of a Colpitts oscillator before. Please watch the video to understand the functioning of the oscillator that we are going to do now. In this circuit, the oscillator stage consists of two NPN transistors that are directly coupled to each other. These two transistors are connected as a Darlington pair where the emitter of the first transistor is connected to the base of the second transistor. The collectors of both transistors are joined together at the common positive terminal. This configuration provides higher current gain and stability to the oscillator than using a single transistor. The direct coupled transistor Colpitts oscillator circuit is wired around the base and emitter terminals of the first transistor. The LC network at the base circuit of the first transistor determines the frequency of oscillation. The capacitive divider network provides feedback for the oscillation. A resistor is connected between the emitter of the first transistor and the ground for biasing it. The frequency of oscillation can be varied by using a variable capacitor or inductor. The second transistor functions as a buffer amplifier in an emitter-follower type configuration. The output from the oscillator is taken from the emitter of the second transistor using a small value coupling capacitor. The frequency drift as seen in a typical Colpitts oscillator is minimized in this oscillator due to less pulling by the subsequent stages of the oscillator. It also provides some additional power gain at the output. The oscillator can be widely used in general coverage receivers, signal generators, transmitters, and transceivers. This is another bipolar transistor based oscillator. Um, we have three bipolar transistors, and the first one act as a oscillator, and the second transistor is also directly connected to the first transistor. So the emitter of the first transistor is directly connected to the through this connecting jumper wire to the base of the second transistor. So these are directly connected, directly coupled bipolar transistors, and the first transistor acts as an oscillator, and all the feedback elements are connected with the the emitter of this first transistor, and also that the emitter is directly coupled to the base of the next second transistor. So the first transistor acts as an oscillator, and it couples directly to the second transistor, which can act as a buffer amplifier, and all the other feedback, the frequency measure determining component, the tank circuit composed of this coil and the capacitor, the coupling capacitor. This is a 100 pf capacitor, and the feedback capacitors, and the emitter resistor, and the second transistor act as a amplifier. It amplifies the signal output from the emitter. It's a common collector transistor, so it's a emitter follower type of the buffer stage. So the from the emitter we couple using a small PF value to the base of the third transistor. So these are the basic configuration: oscillator, buffer, and the RF amplifier stages. So I'll just connect the output, power supply, and I'll also connect the. So here you can see the output in the frequency counter. It's showing 6.0. So I can adjust the frequency using this variable capacitor. I can just rotate the shaft of this variable capacitor and adjust the frequency from 4 megahertz, 4.079 megahertz up to 7.500 megahertz. So this is a direct coupled oscillator, and this oscillator the configuration is based on the Colpitts oscillator, but these transistors are directly coupled, so that is the difference. It's a directly coupled BJT oscillator buffer oscillators. Oscillator buffer type of the VFO, variable frequency oscillator. The advantage of this is that it has more stability than other oscillators. It can also be used in radio receivers, transmitters, and many other applications. Okay, so thank you.